successor. Given any natural number, we can always get the next natural number simply by adding 1 to the given number. For example, the next number to 469 will be 469 plus 1, that is 470. We say that 470 is the successor of 469. Successor is the number that comes just after a given number. Here are some examples. Successor of 99 is 100. Successor of 682 is 683. Successor of 423 is 424. And successor of 581 is 582. Similarly, predecessor is the number that comes just before a given number. For example, the previous number to 469 will be 469 minus 1, that is 468. We say that 468 is the predecessor of 469. In the same manner, predecessor of 91 is 90. Predecessor of 544 is 543. Predecessor of 25 is 24. Predecessor of 82 is 81. To understand the concept more clearly, look at the animation. Consider the man wearing a red shirt. The person standing in front of him is his successor, and the person standing behind him is his predecessor. Whole numbers, natural numbers along with 0 from the collection of whole numbers such as 0, 1, 2, 3, 4 and so on are called whole numbers. This is a number line for the whole numbers. The distance between 0 and 1 is called unit distance. Numbers are marked at unit distance on the number line. Consider the numbers 2 and 6. The distance between them is 4 units. Now, let us see how to compare two numbers on a number line. The number on the right of other numbers is the greater number. For example, 6 is greater than 4. So, as we go from left to right, the number increases. Similarly, any number on the left of other numbers is the smaller number. 4 is less than 6. Consider the numbers 8 and 1. On the number line, we see that the number 8 is on the right side of 1. This number 8 is greater than 1. That is, 8 is greater than 1. So we say that out of the two whole numbers, the number which lies to the right of the other number is greater. Mathematical operations using number line. Now let us add 5 and 3 using number line. To add 3 to 5, we move 3 unit steps to the right of 5. We reach 8. So, 5 plus 3 is 8. Now to subtract 3 from 6, we move 3 unit steps to the left of 6. So we get 6 minus 3 is 3. Let us now find out the product of 2 and 3. We know that the distance between 0 and 2 is 2 units. Now, as we need to multiply 2 with 3, we move 3 times this distance. We reach 6. So, 2 into 3 is 6. Properties of whole numbers. Closure property. We have some properties on whole numbers which enable us to understand whole numbers better and make calculations simple. Let us take any two whole numbers and add them. What did you observe? Yes, the sum of these numbers is also a whole number. Hence we say that the sum of any two whole numbers is a whole number. Or we say that the collection of whole numbers is closed under addition. This property is known as the closure property for addition of whole numbers. Similarly, the product of any two whole numbers is again a whole number. So whole numbers are closed under multiplication also. But they are not closed under subtraction, as difference of two whole numbers may not always be a whole number. Look at these examples. Difference is not always a whole number. Similarly, whole numbers are not closed under division. On dividing two whole numbers, we do not get a whole number always. Commutative property. Look at this animation. 4 marbles plus 3 marbles is equal to 7 marbles. Also, if we add 3 marbles to 4 marbles, we get 7 marbles. In both the ways, we get 7 marbles. So we see that either we add 4 to 3 marbles or 3 to 4 marbles. We get the same sum. Look at the number line given here. 1 plus 5 is 6. Also 5 plus 1 is 6. So 1 plus 5 is same as 5 plus 1. This property, in which the order of addition does not matter, is known as the commutative property of addition. That is for any two whole numbers a and b. A plus b is always equal to b plus a. Sherry plants 5 rows of saplings, with 3 saplings in each row in her garden. The number of saplings she requires is 5 into 3, that is 15. Now instead of 5 rows, she plants 3 rows of saplings with 5 saplings in each row. She observes that the number of saplings remain the same, that is 3 into 5 equals to 15. So we get 5 into 3 equals to 3 into 5. It is true for any two pairs of numbers. This property, in which we can multiply two whole numbers in any order, is known as the commutative property of multiplication for whole numbers. That is, for any two whole numbers a and b, a into b is equal to b into a. Subtraction and division are not commutative for whole numbers. Look at these examples. 5 minus 2 is not equal to 2 minus 5. 8 minus 3 is not equal to 3 minus 8. Also 4 divided by 2 is not the same as 2 divided by 4. In the same manner, 15 divided by 3 is not the same as 3 divided by associative property. Similarly, we have associative property for multiplication. Look at these 3 jars. Jar A contains 5 marbles, jar B contains 7 marbles, and jar C contains 10 marbles. Now marbles in A plus marbles in B is equal to 5 plus 7, that is 12. Adding marbles of jar C, we get 12 plus 10 is equal to 22 marbles. So we have 5 plus 7 plus 10 is equal to 22. Similarly, marbles in B plus marbles in C is equal to 7 plus 10, that is 17. Adding marbles of jar A, we get 17 plus 5 is equal to 22 marbles. So we have 5 plus 7 plus 10 is equal to 22. From this animation, we see that 5 plus 7 plus 10 equals to 5 plus 7 plus 10. This property is known as the associative property of addition. That is, for any three whole numbers a, b and c, a plus b plus c is equal to a plus b plus c. Now if we want to find the product of 4, 2 and 5, we can first find the product of 4 and 2 and then multiply it by 5, or first find the product of 2 and 5 and then multiply it by 4. In both the conditions, the result will be same. This is the associative property of multiplication. That is, for any three whole numbers a, b and c, a into b into c is equal to a into b into c. Again, this property does not hold for subtraction and division. Distributivity of multiplication over addition. Let us simplify the expression 2 plus 3 into 4 and 2 plus 3 into 4. In the first expression, we add 2 plus 3 and then multiply the result by 4. While in the second animation, we first multiply 3 by 4 and then add 2 to the result. So we get the value of the first expression as 20 and the second as 14. So we see that the two expressions are not equivalent. Hence, the order of addition and multiplication does matter. From the animation, we can see that the 2 and 3 must both be multiplied by 4. So, we multiply 4 by both the numbers. That is, we distribute the multiplier to each number in the parenthesis. This is called the distributive property of multiplication over addition. Now let us find the product of the two numbers 19 and 45. We use the distributive property to find this product. Can we write 45 as 40 plus 5? Yes, we can. So our expression changes to 19 into 40 plus 5. Now on opening the brackets, we get 19 into 40 plus 19 into 5. This gives us 760 plus 95, which is equal to 855. There is another way of solving the above expression. We can write 45 as 50 minus 5 also. Then 19 into 45 becomes 19 into 50 minus 5, or 19 into 50 minus 19 into 5, which again gives the same result on solving. Identity for addition and multiplication. What happens when you add 0 to a whole number? Let us see. Yes, we get the same whole number again. A number remains unchanged when added with 0. So we say that 0 is the identity for addition. That is, the sum of 0 and any number is the number itself. Similarly, in the case of multiplication, when 1 is multiplied to any number, we get the same number. So we say that 1 is the identity for multiplication. Patterns in whole numbers. Whole numbers can be represented through various patterns. One of the ways is by using dots. The numbers excluding 0 and 1 can be represented by using dots through various patterns such as lines, rectangles, squares, and triangles. Every whole number can be represented as a line, 2, 3, 4, 5, and so on. Some numbers can be shown as rectangles, such as 4, 6, 8, 10, and so on. Also, some numbers can be shown as square, 4, 9, 16, 25, and so on. Note that we get the next number by adding consecutive odd numbers. There are numbers that can be shown as triangles, such as 3, 6, 10, 15, and so on. Note that these numbers follow a pattern. These numbers are obtained by taking the sum of consecutive whole numbers. Patterns observation. Here, we shall use patterns to simplify our calculations. Consider the expression 1,23,45,678 plus 99,99,999. It looks difficult to find the value of this expression, isn't it? Let us find a way to make our calculation easy. Observe 99,99,999. Now observe these patterns. Here we have written 9 as 10 minus 1, 99 as 100 minus 1, and 999 as 1000 minus 1. Now observe the first expression. 152 plus 9 is equal to 152 plus 10 minus 1. Using associative property of addition, we can first add 152 plus 10, that is 162. And then we can subtract 1, which finally gives us 161. Similarly, in the next expression, 268 plus 99, we have written 99 as 100 minus 1. Again, we first add 268 and 100, that is 368, and then subtract 1. We get 367 as the answer. In the same manner, we can get the value of the last expression. Now returning back to the original expression, we can write 99,99,999 as 1 crore minus 1. Again, by using the associative property, we get the value of expression as 2,23,45,677. Now let us change our expressions to subtraction type. Keeping the numbers same, we have just changed the addition sign to subtraction. Note here, on opening the brackets, minus 1 becomes plus 1. So we now first subtract 10 from 152 and then add 1. We get 142 plus 1, or simply 143. Similarly, we find the value of the other expressions. Coming back to the original expression, we again write 99,99,999 as this, and then open the brackets to simplify the expression to obtain the value 23,45,679. Now let us observe another pattern involving multiplication of 9s. Again we write 9 as 10 minus 1, 99 as 100 minus 1, and 999 as 1000 minus 1. So we have 68 into 9 is equal to 68 into 10 minus 1. 54 into 99 is equal to 54 into 100 minus 1. And 77 into 999 is equal to 77 into 1000 minus 1. Using distributive property, we can write 68 into 10 minus 1 as 68 into 10 minus 68 into 1, which equals 680 minus 68, or simply 612. 54 into 100 minus 1 can be written as 54 into 100 minus